Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel, Assistant Professor from LJIT. Today's session we are going to discuss with system of non-homogeneous linear equation. Earlier lecture we are already discussed about the rank of matrices. Basically linear system has two types, non-homogeneous linear equations and homogeneous linear equations. Today's session we are discuss with the system of non-homogeneous linear equations. A system of m non-homogeneous linear equations in n variables like as x1, x2, x3 up to xn is a set of m linear equations each in n number of variables. A linear system can be represented as a11 x1 plus a12 x2 plus a13 x3 up to a1 and xn equal to b1. Second one equation which is a21 x1 plus a22 x2 plus a23 x3 up to a2n xn equal to b2. Continuing this manner, mth equation which is am1 x1 plus am2 x2 plus am3 x3 and so on amn xn equal to bn. This system of linear equation can be written in form of matrices form. That means our matrices form is ax equal to b, where capital A equal to a11, a12, a13 up to a1n. In second row a21, a22, a23 up to a2n. Continuing this manner am1, am2 up to amn, where capital X equal to the in column matrices x1, x2, x3 up to xn is the any vector of the order n cross 1. Similarly, capital B equal to the b1, b2, b3 up to bm is any vector of the order m cross 1. Here, starting with the solution of the system of the linear equation. Basically, for a system of m linear equations in n unknowns, there are basically three possibilities to finding the solution of that particular system. First is system has a unique solution. Second one has a system has a infinite solution. Third one, system has a no solution. When the system of linear equations has one or more than one solution, then we can say that our system is consistent, otherwise it is inconsistent. Here, if our system has unique solution and infinitely many solution, means that is indicated by the consistence. If our system has a no solution, that is indicated by the inconsistent. Means if determinant not equal to 0, then we can say that our linear system has a unique solution. Unique solution means whatever the variables, suppose we have the three unknowns x1, x2, x3, then for the reducing the row echelon form of or a reduced row echelon form, then we get total three leading elements. If we have the infinite many solution, that means suppose we have the unknowns 3 or we get the less than 3 leading elements, then we can say that we have the infinite many solution, or our system has a is equal to something, means whenever the column matrix b1, b2, b3, means whenever we have the leading element position and opposite side leading element position that is 0 and opposite side our constant term which is non-zero, means 0, 0, 0 and 5, then we can say that system has no solution. Let's see solution of the system with the help of augmented matrices. Means A oblique B, that is our augmented matrices, which is a11, a12 up to a1n slash b1, a21, a22, a2n slash b2. Continuing this manner, am1, am2 up to amn slash bm is called the augmented matrices of the given system of non-homogeneous linear equation. To solve the system of linear equation, by the elementary transformation are used to reduce the augmented matrices to the either row echelon form or a reduced row echelon form. Let's start with a Gauss elimination method. Reducing the augmented matrices to the row echelon form is called the Gaussian elimination method, or we can say Gauss elimination method. For the Gauss elimination method, for solving the non-homogeneous linear system equations are follows the steps. In step 1, firstly, whatever the linear equation which is given and converting into in a augmented matrices, means write the augmented matrices. Now obtain the row echelon form of the augmented matricing by using elementary row transformation. In third step, write the corresponding the linear system of the equations from the row echelon form. Now in fourth step, to solving the corresponding linear equations by the back substitution method. Let's start with one example. Solve the following system by Gauss elimination method. First equation, which is x plus y plus 2z equal to 9, 2x plus 4y minus 3z equal to 1, 3x plus 6y minus 5z equal to 0. Here is equal to not equal to 0, means is equal to something value 9, 2, 3 minus 4y, whatever the value. That means we can say that it is non-homogeneous linear equation. Firstly, whatever the linear equation which is given, which is written in form of matrices, means the matrix which is in form of Ax equal to B. Then here, whatever the coefficients of the variables x, y, z, which is written in first column, first matrices, that is our 3 cross 3 matrices, because here we have the total 3 unknowns. Then our augmented matrices becomes 3 by 4. Means our matrix which is Ax equal to B, that will give you 1, 1, 2, 2, 4 minus 3, 3, 6 minus 5, that is our capital A matrices. Here capital X, that is unknown variables, that is x, y, z in a column matrices, is equal to B, capital B, that is equal to something, that is B1, B2, B3. Here 9, 1 and 0. Now written this matrices in form of augmented matrices. Then A slash B, that will written in form of 1, 1, 2 slash 9, 2, 4 minus 3, 1, 3, 6 minus 5, 0. Here you can write in form of slash, otherwise gem, otherwise simply space or 910. You can write any method, oblique line, otherwise slash, otherwise gem. You can any symbol as a return in augmented matrices. Firstly, reducing the augmented matrices to the row echelon form or a reduced row echelon form. If you have to apply the row echelon form, then we can say that it is Gauss elimination method. Suppose you can apply to the reduced row echelon form, then we can say that it is Gauss-Jordan method. Firstly, for the applying the row echelon form, then first leading element 1, making the below entry of that particular element to the 0 with the help of row operation. Here applying the R2 minus 2R1 and R3 minus 3R1, that will give you 112 slash 9, 02 minus 7 slash minus 17, 03 minus 11 slash minus 27. Now first leading element 1, bottom entries of that particular element already making the 0. For the making the leading element in second row, for that divide by row 2 by 2, that means 1 half R2, that will give you 1129, 01 minus 7 by 2 minus 17 by 2, 03 minus 11 minus 27. Now with the help of that particular element, means that leading, making the third row element as a 0, for that applying the operation R3 minus 3R2, and our matrices becomes 1129, 01 minus 7 by 2 minus 17 by 2, 00 minus 1 half minus 3 by 2. Now making the in third row has a leading 1, for that multiplying with minus 2 in third row, that will give you 1129, 01 minus 7 by 2 minus 17 by 2, 0, 0, 1, 3. This is our exactly row equivalent form. Now, with the help of that matrices, we written in form of equations, means our corresponding system of the equation is in first equation from the first row, that is x plus y plus 2z equal to 9. In from the second row, y minus 7 by 2 z equal to minus 17 by 2, that is our equation number 2. For the third row, z equal to 3, that is our equation number 3. Then we have already values of z. Then substituting these values of z equal to 3 in second equation, then that will give you values of y. That means y minus 7 by 3 into 3 equal to minus 17 by 2. For solving this equation, and that simplified it, and we have two values of y, that is exactly 2. Now substituting these values of z and y in our equation number 1 and simplified it, then our equation 1 becomes x plus 2 into 3 equal to 9, and simplified 8, then values of x, that is 1, means our system has a unique solution, or values of x, y, z, that is 1, 2 and 3, means our system is a consistence. It is called the consistence. Now let's see one more example. Solve the following system by Gauss elimination method. 3x plus y minus 3z equal to 13, 2x minus 3y plus 7z equal to 5, 2x plus 19y minus 47z equal to 32. Firstly, whatever the system of linear equation which is given, which is written in form of matrices, that is the matrix which is in form of Ax equal to b, then firstly whatever the coefficient of the x, y, z, that is written in form of capital A, that will give you 3, 1 minus 3, 2 minus 3, 7, 2, 19 minus 47, and capital X, that is the count of variable. Here x, y, z, that is our variable, that is written in form of column, that is x, y, z equal to capital B, that is equal to something constant value. Here 13, 5 and 32, which is written in form of column. Now our augmented matrices of the system is A oblique B, that is 3, 1, minus 3, 13, 2, minus 3, 7, 5, 2, 19, minus 47, 32. Now reducing this augmented matrices to the row equivalent form, you can reduce to the row equivalent form as well as reduced row equivalent form, as you like. If you have converting to the row equivalent form, that is called the Gauss elimination method. If it is converting to the reduced row equivalent form, that is called the Gauss Jordan method. Here I applying to the in form of row equivalent form. For the making the leading element 1 in first row, for that divide by first row by 3, means 1 by 3 into R1, then our matrices becomes 1, 1 by 3, minus 1, 13 by 3, 2 minus 3, 7, 5, 2, 19 minus 47 and 32. With the help of that leading element, making the bottom entries of that particular element to the 0. Then for the applying the row operation is R2 minus 2R1 and R3 minus 2R1. That will give you 1, 1 half minus 1, 13 by 3, 0 minus 11 by 3, 9 minus 11 by 3, 0, 55 by 3, minus 45, 17 by 3. Now our matrices has the first leading bottom elements of the 0. Now second, making this second row as a element, leading element, for that multiplying with minus 3 by 11 to the second row, that will give you 1, 1 by 3 minus 1, 13 by 3, 0, 1 minus 27 by 11, 1, 0, 55 by 3, minus 45, 70 by 3. Now for that leading element, making the bottom entries of the third row to the 0, for that applying the operation R3 minus 55 by 3 R2, that will give you 1, 1 by 3 minus 1, 13 by 3, 0, 1 minus 27 by 11, 1, 0, 0, 5. Here in this particular example, making the last entry become 1, for that 1 by 5 into R3, that will give you 1, 1 by 3 minus 1, 13 by 3. 0, 1 minus 27 by 11, 1. 0, 1. Here in last row, we can return in form of row of the row equivalent form of the augmented matrices. We have 0x plus 0y plus 0z equal to
1.
that means we have the total two leading elements, and in last row has a 0 and something not equal to 0, means 0x plus 0y plus 0z equal to
1.
that means our system has a no solution. That means our given system of linear equation which is inconsistent and it has no solution. These all are the practice example. Do yourself, try to solve and finding the system has unique solution, infinite solution and no solution with the help of Gauss elimination method or with the help of Gauss Jordan method. This is all about the topics of the system of non-homogeneous equations. If I hope you guys you learned something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.